In this video, I'm going to talk about the different types of sampling techniques that you can use in building predictive models. So why do we need sampling? Well, we all know that in inferential statistics, we deal with samples, not with population most of the times. So when it comes to making an inference or doing a prediction, we always go in for a sample data instead of a population data, because of a variety of reasons. One of the main reason is that the population data is usually very large and very difficult to deal with. Hence, we go ahead with sample data. We just extract a proper sample from the population data and make inference about the population. Okay, because population is very large to handle. So that's one of the reason of using the sample data instead of a population data in doing prediction or deriving inference for your population. All right, so let's understand what is sample and what is a population. A population is a collection of observations about which we would like to make an inference. So it's a whole lot of the collection of observations, and that's what we call it as a population. Sampling, on the other hand, sampling units are non-overlapping, and that's an important word to highlight. It should be non-overlapping units. Sampling units are non-overlapping collections of elements from the populations. So sample is basically a subset of population in which it has got non-overlapping elements. Okay, as you can see in this example, here we have a population data, and we have got sample from it by selecting one of the type of element from the population. We have got a square, we have got a triangle, and we have also got a circle. So that's basically is a sample derived from the population. And that's basically the difference between a sample and a population. Of course, you can get into the details of it. There are more differences, noteworthy differences, which we'll discuss in this particular session. One thing we come across in inferential statistics or while building models using samples instead of a population is what we call as the sampling error. Sampling error is defined as the deviation between the estimate. So remember, when we build a predictive model, we find out the estimates. So the deviation between the estimate of an ideal sample and the true population. Now, if you build a model using a true population and you build a model using a sample from the population, then the difference or the deviation of the estimate from a sample data from that of a population data is what is known as a sampling error. Okay. So the objective all the time should be to minimize the sample error, the sampling error. Okay. So whenever we are building a predictive model, we need to ensure that we minimize the sample error so that the model will be very representative or should be very good to derive inferences about the population or do the prediction for the population data. What are the types of sampling? At a broad level, sampling can be of two types. One is probability samples, and then the other one is non-probability samples. So the sample that you derive or you extract from the population can at a broad level be categorized into two types: probability samples and non-probability samples. So what is a probability sample? Well, in probability samples, each member of the population has a non-zero probability of getting selected. So it is very random in nature. So every time you get a probability sample, what you do is that you choose an element or a member of the population at random. Okay. So each and every element of the population has a non-zero probability of getting selected in the sample. Okay. And the examples of probability sampling are random sampling, systematic sampling, stratified sampling, and so on. The second category of sampling is known as the non-probability samples. In non-probability samples, members are selected from the population in non-random way. That means it is somewhat biased. Okay, it is more of an opinion based. Okay, you don't select the elements from the population in your sample randomly, or by generating random numbers, or tossing a coin, or throwing a dice, such random experiments. You rather use your judgment in order to select elements from the population to be in the sample. And the famous examples are the convenience sampling, judgement sampling, quota sampling, snowball sampling. So let's try to understand what are the sampling techniques, what are the probability sampling techniques and the non-probability sampling techniques we have just mentioned in this particular slide. The first one we'll see is what is known as a random sampling. In random sampling, each member has equal probability of getting selected. So if you have this as a population, let's call this population as A. In population A, we have got 10 elements from 1 to 10. Let's say that these elements are nothing but 10 customers. And we need to find out, let's say, 4 samples or 4 sample customers from this population. Okay. And we call that as B. Okay. Now the probability that the customer 1 will be selected is 1 by 10. Okay, because it's equally likely. Okay, because there are 10 elements in this particular population, and each element is equally likely to be selected. Let's assume that that's one of the criteria of selecting the element from the population. So if you have to select 4 elements out of these 10 elements in the population, we can get any one of these 4 elements, because each one of these population elements is equally likely to be in the sample B. Okay, and why we call it as random sampling? Because we do not select by judgment. Rather, we just do an random experiment and select elements from this population. That's why it's called random sampling. And we also, you might have come across what is known as a simple random sampling, which is probably the most popular sampling technique used in building predictive models. Remember, the probability that each one of these element selected from the population to be in sample could actually vary. We are assuming here it's constant for all the sampling the elements, for all the elements, but it could actually vary. Systematic sampling. In systematic sampling, what you do is you select every nth record from the population data. So here is an example. We have got this population, and we have got 12 customers, let's say, and marked from 1 to 12, and we want customers whose numbers are divisible by 4. Okay, so we start with 4, and then the next one will be 8, and the next one will be 12. So we just selected 3 out of this 3 elements or 3 customers from this population, and that's our sample in this case. Okay, remember one thing here, n should be random, okay, most of the times, and the rule that we use, that it has to be divisible by 4, need not be same. It could be anything. It could be divisible, it could, the number could be divisible by 2, 3, or there could be some other rule. There's completely different rule. Okay, so n should be random. Okay, you can start from second customer, third, fifth, sixth, anything, but the rules should be uniform. For instance, in this case, there should be a fixed interval between the two consecutive elements selected from the population in the sample. So that's called systematic sample, and this is useful in cases where generating random numbers is difficult or expensive affairs, because generating random numbers is computationally intensive. So in the previous case where we saw what is a simple random sampling is, you need computational power, but this is much simpler, and in case you don't have access to high computational power and it's a large sample, you can go ahead with systematic sampling. The third one is called stratified sampling. In stratified sampling, there are two steps to be followed. One is identify the suitable stratum in the data. So you could have multiple strata in your data, right? You can have data like data for male and female, or in other cases you could have data for different demographic. Let's say you can have data for let's say California, you can have data for Washington, any other city, San Francisco, Los Angeles. Yeah, so you can possibly have different strata of data population, and you probably want to have random sampling within each strata or within each stratum within the population. So for instance, in this example we have got data for male and female, and we want a random element to be selected from male as well as from female. Okay, so we divide the population into two categories, male and female. So that's the first step. In the second step, we selected a sample from this strata, from each of these strata, and each element is selected from a particular stratum is equal likely. So the probability of 1 selected, 2 selected, up to 5 is exactly same. It's 1 by 5, whereas there are 6 elements in the female population. So we have got the probability of each element from female population is 1 by 6, because there are 6 elements in this case. Alright, so that is stratified sampling, and this is very popular in predictive modeling, because in predictive modeling you want each of your stratum to have equal representation in your study. Okay, and that's very important. Sometimes in your sometimes you want data from each gender. Sometimes you want data from each cities that you were doing the study. Sometimes you could have data where you want equal representation from each category of data. Okay, and in that case stratified sampling is very handy, and it's very popular, by the way, in predictive modeling or any data science project that you are doing nowadays. Cluster sampling. It is done in 2 stages, so it's a 2-stage process. In the first stage, you just select the clusters from the population by random. Okay, and in the second stage you select elements from each cluster, and that's also by random, and it's very popular in market research. So just to take an example, so we have got this population, and in this population there are 5 different categories or 5 different clusters. So I've denoted the clusters by different geometrical figures. So there is square, triangle, hexagon, a circle, and a rectangle. Okay, now we have got 5 clusters in our population, and we will just select few of these clusters. Let's say, for instance, we select 2 clusters of these 5 clusters randomly. So we will use the random sampling to select 2 clusters out of these 5 clusters, and we have selected only so when we do that random experiment, we have selected this square and the circle, and from these clusters we select elements by random. We use this simple random sampling technique to select elements from each one of these clusters. So from the cluster square, we just selected 1, 4 and 5. 1, 4 and 5. And what has been selected from circle are 11 and 12. And that's done purely randomly. It's not based on any judgment or an expert judgment. It's purely done with random experiment. Alright, so each one of these element from the respective cluster is equally likely to be there in the sample. So that's the way you do a cluster sampling. Now, whatever sampling techniques we have studied so far is under the probabilistic sampling. Okay. Now we'll see some of the non-probabilistic sampling techniques. Okay. The first one is the convenience sampling. In convenience sampling, we use elements from the population which are very convenient to select. So a sample is selected best because it is convenient to select from the population. Not all elements are convenient to select, and this is useful in survey data analysis, where you cannot actually reach out to each and every element or every observation or every element of your population. It's difficult, it's an expensive affair, or it's operationally very difficult. In that case, you just go ahead with the cases where it is convenient to select a subset of subset of the population, a sample of the population. Okay, and this is primarily used in cases where you want to do some study on on the population, which can be considered as an initial study. So it cannot or it may not be the final study, but you just want to do a quick study which can be considered as an initial study, which would involve very less cost. You do not want to spend money on going ahead with a very large sample which is very representative and completely random, because that would be very costly affairs. Just go ahead with a very select set of sample members which are very convenient to reach out to. Now, one of the example is the Facebook poll, or the questions people ask on Facebook. You can actually go ahead with your own friend circles because they are easier to reach out to, right? Here is an example. There is a Facebook like status somebody has done, and has found that Donald Trump has been liked by, let's say, 10% of the people, and Hillary Clinton has been liked by 5% of the people. And this is done within a group. Okay, it could be your friend circle, it could be a Facebook group or a WhatsApp group, or so on, or somebody doing a survey on Twitter, right? So so that's convenience sampling. The second one is judgment sampling. In judgment sampling, the sample is selected through judgments, pure judgments. There is no random experiment, so to say. The researcher who is doing the survey or who is doing the predictive model is very sure about the sample being representative of the population. So it's purely based on the expert opinion. Somebody is an expert in the matter, and he's just speaking from the population. Just picking elements from the populations which is to be considered as the representative sample for the population. And this is very popular in many cases, especially cases where you do not have access to the complete population, and you just have to go ahead with what the expert says. This is very important in cases where the area is very niche and access to all the elements or all the observation in a population is very difficult, or either the population is very large enough to reach out to. So in that case, you just go ahead with expert opinion and come up with the sample from your population. So purely based on judgment. The next one is the quota sampling. In quota sampling, you have got two steps. there are two stages in quota sampling. In the first stage, you just identified the stratum and their proportion. So which category or which category of data is to be selected, and secondly, what is the proportion of the data that is to be selected from each category. Okay, and then use convenience or judgment sampling. Okay, just use one of them. So here is an example. We have got a market research to be done in different Indian cities, and there are 4 cities selected. So we have identified that we'll only go ahead with the metro cities from India: Mumbai, Delhi, Kolkata, and Chennai, not any other city. So that is done in the first step. So that is also purely on judgment. And in the second step, also in the first step, we also have to decide what should be the proportion. So we have decided that from Mumbai, 35% of the samples should be there. From Delhi, there should be 20%. And from Kolkata, there should be 20%. And from Chennai, that should be 25%. And then once that is decided, you go ahead with the judgment sampling. So you just select the elements from each one of this category purely on judgment, or purely on convenience. Like if somebody is easily reachable, just go out to him and select him as part of your sample. It's very important in market research, areas where you're doing surveys. Okay, so this is useful for social science and management research scholars. The next one is snowball sampling. It's used when the elements are hard to locate. Okay, it's very difficult to find out which elements are to be picked. You actually do not know your population very well. In that case, you go ahead with what is known as snowball sampling. The sample is rare to find. So you start with the initial elements, and then the initial elements will refer you for the further or to finding out the further elements or the elements to be selected in future. For instance, you go ahead with let's say to some tribal community, and you want to find out people who have a particular type of disease and you do not quite have access to such data in the tribal community, because getting access to data in tribal population is very difficult. So you just go ahead with one particular person in a village and ask him that whether you have a particular disease, and if he says yes, and if this is, you select him, and then ask him that who else in your village has also has the same disease, and then he will refer to the second person, and again you select him in your sample, and you can simply follow the same process. So that's known as the snowball sampling. Thanks.